Alright, so this is part 2 of our 8.3 and 8.4 video lesson. So I wanted to start off this video by showing you the derivation of a certain formula you're going to need for this section. So first off, we know that in a triangle, there are 3 sides to our shape, and the sum of all the angles in a triangle are 180 degrees. In a quadrilateral, you know that there are 4 sides, and the sum of those angles adds up to 360. So if we start with this simple pattern, we want to try to figure out, hey, how many degrees do all the angles in a pentagon add up to? Well, one thing to note is that if I try to compare the angle sum to the number of sides, each time I increase the number of sides by 1, I increase the degrees by 180. And we do end up showing that that is true, but we're going to generalize that into something a little easier for us to understand. So for a 5-sided figure, there's going to be 360 plus 180 degrees, which is 540 degrees. So that means all the angles in a pentagon, all 5 of them, need to add up to 540 degrees. But how can we make this work for any number of polygons, of sides for a polygon? Well, here's what we do. We try to find a pattern like math magicians. So with the number of sides, I notice that if I take away 2 from the number of sides, that 180 is equal to 180 times 1. Okay, nothing fancy there. Nothing fancy at all. But notice that this will extend and hold true if I take away 2 from 4, and that's the same as 180 times 2. So again, take away 2 from the number of sides, and then you multiply by 180. Does this hold true for 540? The answer is yes. 540 is the same thing as 180 times 3. Well, 3 is the same as 5 minus 2. So in general, for any number of sides, for any n-gon, could be a hexagon, decagon, 20agon, you will use the formula n minus 2 times 180 degrees. So we're going to go ahead and write that formula in the first box on our second page. So on example 1 right here, we want to find the measure of the interior angles of our 15gon. So again, for a 15gon, which, mind the typo, that means n equals 15. So start off with your formula. You know that n minus 2 times 180 will give you the angle measure, or the sum of the interior angles. So then I replace 15 for n times 180. Well, 15 minus 2 is 13 times your 180. And that should give you 2,340 degrees. Simple as that. Nothing crazy, nothing fancy. Just straight plug in and calculating. Now, example 2, notice we start off with giving you the sum. The sum of the measures of your angles are 720. How many sides does the polygon have? That is a great question. How many sides? Well, since we know the sum, start off with what you know. We know the formula. Set it equal to the given information. Now we have a nice algebraic expression we can solve. we can either distribute the 180 into both terms and then solve it, or you can make your life a little easier and divide both sides by 180. That will allow you to clean up any big numbers, and so then you're left with n minus 2 equals 720 divided by 180 is 4. Back to algebra land, we're going to add 2 to both sides. So then we find that n equals 6. Now, the question does not say what shape is it. So we don't have to say it's a hexagon. It's just asking how many sides is our shape. So we say it's 6 sides. Now the question is, what if I want to find the measure of one interior angle? Well, one interior angle would imply that I know what the sum is, and once I know how many degrees they all add up to, I'm going to divide by the number of sides I have, which should be the number of angles that I have. And remember that this is only used for a regular polygon. You can't do this for anything that's not regular because the angles wouldn't all be equal. This only works because all those angles are congruent to each other. So we're going to take our previous formula, n minus 2 times 180, divided by the total number of sides that you're given. We can extend this idea a little further down the road, but I'm going to show you the relationship that this has with something else. Right here, we also have the exterior angle sum. Before I go too far, I want to first explain what an exterior angle is. If you notice at each of these corners of the shape, we've extended a line that goes beyond the shape. These angles here are your exterior angles. We do not draw a shape and say the entire thing is the exterior. We don't call that the exterior. That is a no-go. Now this theorem states that no matter what shape you have, it could be a 5-sided shape, it could be a 500-sided shape. No matter what you have, all of those angles that we form on the outside is always 360 when you add them all up. Now what's nice about this is we say, hey, if it always adds up to 360, then I could find the measure of one exterior angle. And again, this only works for a regular polygon. And all I have to do is take 360 and divide it by the number of sides that I have. So, doesn't matter if you have 5 sides, doesn't matter if you have 10 sides, 20, whatever. It'll always work. 360 divided by the number of sides. So we're going to go ahead and try this one here. I want to find my exterior angle first, and then I want to find one of my interior angles. If you want to give it a try, go ahead and pause the video now, and then try using the formulas we just gave you. Alright, so the exterior angle, remember we said was 360 divided by the number of sides I have. Well, since I have a pentagon, that means n equals 5. So, 360 divided by 5, I believe that gets you, what do we say, 72 degrees? Something like that. Now, for my interior angle, I can use my formula that I gave you 2 boxes ago, which says n minus 2 times 180 all over n. Well, we know what n is. N is 5. 5 minus 2 times 180 all over 5. Now, if you're careful with how you type this in your calculator, you can do it in one go. Otherwise, work it one piece at a time. There's no harm. There's no foul. You should be good. Now, if you type this all in and plug in the numbers, you should get 108. Yay! But wait a second, Mr. T. If I know my exterior angle is 72 degrees, and I know that this entire thing forms a straight line, couldn't I have just done 180 minus my exterior angle? And the answer is yes, you could have, if you saw that pattern right away. So an alternate form for your interior angle you do 180 minus the exterior angle. Well, that would be 180 minus your 72, which, whoa, look at that, is also 108. So that's the end of our examples. That's the end of the lesson. Go ahead and give the homework problems a try. And if you have any questions, don't hesitate to email me or send me a message on Remind. As long as it's not too late, you know I'll answer them. Hope you all are having a good time so far. Right now it's 10:35 my time. Getting a little tired, but hopefully you're not too tired. All right? Talk to you later.